And we're back. For you, it's been a whole day. For me, it's only been a few seconds, okay? Because I'm recording these videos. I'm back. I do back. Maybe you just watch all the videos over the weekend or something like that. So you're like, hey, same thing for me. Bad idea, by the way. You don't want to just try to cram these things in. You want to look at a little bit each day and then practice to keep these things fresh in your mind. Your homework was to find the area of region R. Remember, if you want the area between a function and the x-axis, the regions above, you could just integrate that function. Preferably, if you see the word area, you hear my daughter? Listen. What's going on? Is that my daughter or a train whistle? Oh boy. Anyways, I don't know. I think that's a playful scream, actually, not a crazy scream. So I'll draw that rectangle. Think for area, you should always think about area between two curves. People are like, but there's only one curve, Mr. Berto. The upper curve is y equals x squared. The lower curve is y equals 0, Poppy. And that means the area is going to be equal to the integral upper function minus lower function, x squared, upper function, whatever y equals, minus 0, lower function, whatever y equals. Make sure you put parentheses with respect to x. Bounds are easy here, right? They tell you specifically, it's not intersection points or anything like that. Specifically, you start at x equals 1 and you end at x equals 3. And by the way, same thing as just doing the integral from 1 to 3 of x squared with respect to x. But don't sleep on this over here. As silly as it seems right now, it's going to become more and more useful. AP, there's so many different formulas and things, techniques to remember. You want to kind of focus on things and always do them in a certain way sometimes so that it becomes easier to think about new information, not have to always be thinking about that old information. So basically, whenever you see area, try to use either upper minus lower or right minus left, which we'll talk about next year. Anyway, this is as easy as it gets, right? Integrate x squared, you get x cubed over 3. Evaluate it from 1 to 3. This is the joke of the year here. Cube that 3, you get a 27 divided by 3 is 9. Let's actually do this. That's silly to write a 9. I'll just leave it as 27 over 3. Are you thinking about that? Are you thinking that far in advance? People are like, why wouldn't you just make that 9? Well, why not? Good. If you plug in the 1 right here, now you get 1 cubed over 3, which is 1/3. If this is 9 minus the third, I'd have to make the 9 into a 27 over 3 again. This is 26 over 3, and bam, there's our answer. Some people are like, hey, can't you simplify this? No, 3 doesn't go into 26, but it looks like it does, right? Anyway, so that's really technically it. No, sometimes I get to this next problem. Sometimes I don't get to this next problem. This year, obviously, getting to this problem. I think it's a great problem, right? So hopefully you have this printed up or you're writing down your notebook. Okay, they tell us let R be the region bounded by the x-axis, the graph of y equals radical x, and the line x equals 4. And then they tell us find the value of h. The heck is that? Such that the vertical line x equals h divides the region R into two regions of equal area. Please show all work. Calculate the value of h by hand. There are a lot of different ways to do this problem right here. Okay, I'll try to focus on the most basic way. First off, why not make the picture, right? The graph of y equals radical x. Be careful before you're just drawing y equals radical x here. Now we have points to worry about plotting. So if x is 0, the square root of 0 is 0. If x is 1, the square root of 1 is 1. Then I'll jump all the way ahead to if x is equal to 4, the square root of 4 is going to be equal to 2. Okay, so then I'll make my y equals radical x that way. It's just a little bit nicer right there. So it's bounded by y equals radical x, the x-axis, which we already have, and the line x equals 4. Okay, nice little vertical line right here. So now we can see the region we're talking about. This is region R. And what we want to do is we want to find the value of h such that the vertical line x equals h, not x equals 4, but x equals h, divides R into two regions of equal area. And some people are like, oh, it has to be at x equals 2. Now, it looks like at x equals 2, you got a little bit less area to the left than you do to the right. I think an h is somewhere probably in between 2 and 3. Not that it matters graphically, okay, because you guys set it up, as far as an integral here. So there's a couple different ways to do this. How do we actually get this area to be equal to this area? Here's the best way to do it. This right here is the area between a function and the x-axis, right? Y equals 0. And this right here is the area between a function and the x-axis. We know we can get that area by integrating the function. I mean, you could even use upper minus lower, right? Here, you can see upper is going to be y equals x, lower is y equals 0. And over here, to the right of x equals h, it's the same, right? Upper is radical x, and lower is going to be y equals 0. But they don't actually want you to calculate the area, okay? They want you to calculate what the value of h is. You know, and think about it. If these two regions have equal area, that means the integral from 0 to h of radical x minus 0 has to be equal to the integral from h to 4 of radical x minus 0. Cool problem. You know, it's actually shown up on an AP in a couple different iterations over the years. But you could say, you know what, I'm going to do the integral from 0 up to h of radical x minus 0 with respect to x. And that right there, that's this area right here, right? The integral from 0 up to h. And now I want to see what value of h will actually make that equal to the area from h up to 4. And that's the integral from h up to 4 of radical x minus 0, all with respect to x. And this is an equation, okay? It's an equation that involves integrals. So I get that's kind of annoying. But still, it's not a horrible problem because you could easily solve it now by getting rid of the integrals by integrating. Do you understand that? Okay, that, you know, the integral from 0 to h is going to be the same as the integral from h to 4 because we want these two regions to have the same area. That's what it comes down to here. And remember, radical x is really x to the 1/2. So when I integrate that, I get x to the 3/2. Rourke is dividing by 3/2. We're multiplying by 2/3. Evaluated from 0 to h. And it's actually really cool over here because you get the same thing. You're integrating the same thing. And you could have used radical x. It doesn't need to be radical x minus 0. But I like the upper minus lower thing, as I've told you many times. So I know I'm going to get 2/3 x to the 3/2 again. But now it's evaluated from h to 4. And right now, you're like, great, Berto, you took something that was ugly and transformed it into something that's kind of more horrific. But when you plug in, things are a lot easier. We get 2/3 h to the 3/2, plug in that upper bound, minus 0, right? 2/3, 0 to the 3/2. That's pretty luscious. Equal to 2/3, screaming children upstairs, times 4 to the 3/2, right? That upper bound, minus 2/3, and once again, times h to the 3/2. So now it's actually an equation only in terms of h. We could solve for h. I'll write it out. Some people struggle with this. I'm going to add 2/3 h to the 3/2 to both sides. And really, they're like terms, right? Just do 2/3 plus 2/3, which is 4/3. Bring along that variable, h to the 3/2 equals, over here, 4 to the 3/2. We get a number over here, right? Square root of 4 is 2. Cube that 2, you get an 8. 2/3 times 8, was that 16/3? You know, now divide by 4/3 on both sides. Some people divide by 4/3 like Rourke. We multiply by 3/4 because it's much cooler to do. Check this out. 3's are canceling. Divide by 4 top and bottom. You know, and now we actually have, sorry you couldn't see that little piece there. Now we actually have h to the 3/2 is equal to just 4. And people are like, well, what do I do now? How do I solve for h? If you forgot to raise both sides to the reciprocal exponent, the heck is going on out there, folks? We spoke about these things. You end up with h to the first, right? Because if you raise a power to a power, you multiply exponents, and 3/2 times 2/3 is 1. That's why we raise both sides to the reciprocal exponent. Number of times the reciprocal is always equal to 1. If you want to solve for a variable, you want the exponent to be equal to 1. It equals 4 to the 2/3. It's not wrong, okay? There was multiple choice or something. You want to say this is really, oh, what is that? Cube root 4 quantity squared. Yeah, that's pretty nasty, okay? So I'll leave it as 4 to the 2/3 right there. You know, if it's a calculator type of situation, I really like 4 to the 2/3 myself. But obviously, with a calculator, it is going to be a rational, approximately 2.5. Check this out, 2.519 if you're a lousy stinking truncator. But it's easier to truncate this than it is to round it, right? Because that 8's going to turn that 9 into a 10. The 10 turns that 1 right there into a 2. So 2.520. So either of those answers are correct. This is the better one because technically you're supposed to do this without a calculator. And there's lots of different ways to do it. I mean, you know, some people, they set up 2 other equations. You could do this. Sometimes people just set up the integral from 0 to h of radical x minus 0 with respect to x. Remember what that is right there. It's not the full area. It's only half of the area. The full area, you know, if you actually wanted the full area, that would be the integral from 0 all the way up to 4 of radical x minus 0 with respect to x. So some people actually take that and they set half the area equal to that full area, which doesn't make sense, okay? But it does if you put a 1/2 in front. So you could have something like that set up. People calculate the full area. They just take half of it. Then they set this integral equal to that half value. That's fine. That works. You know, if you want, you don't even need to use this integral. You could use the integral from h to 4. play with that if you want. Try other ways to do it. But the problem with these ways is it necessitates you calculating what the exact area is, which sometimes gets a little frumpy. So this is probably the best way to do it. That's the way they're usually looking for. Really up to you. Lots of different ways to do these problems. It's an AP problem, so if you're looking at that and you're like, wow, it's kind of tricky, I don't get that. Maybe you're not the type of student who's going to take AP Calculus next year. There's nothing wrong with not taking AP Calculus. I mean, everybody thinks you got to take 12 million APs these days. What, everybody just suddenly becomes smarter? I know you think that, you're like, yeah, well, we have computers and the internet and blah, blah, blah. We must be smarter than people that preceded us. Yeah, I think Einstein might have something to say about that. People are as smart as they always were. People are as dumb as they always were, okay? Just having a bunch of people take these APs, it sounds good, but you could drive yourself crazy. You don't need all those AP exams, okay? You don't need to take AP Calculus next year. There are math teachers teaching in this school who didn't take AP Calculus in high school. Mr. Pushy, look, I'm not making fun of him for being, not intelligent, which he isn't. Just kidding. But ask him; he'll tell you straight up. He didn't take AP Calculus. He didn't need it. He's teaching advanced placement statistics. He's doing great. Okay, besides the fact that he's ugly. So look, you don't need to take all these AP courses. So if you don't feel comfortable about it, you don't need to take AP Calculus. And remember, if you sign up for BC, you better feel more than comfortable. You better know what you're doing. This entire class better have been an absolute joke this year. And you are willing to put in work. If you're a slacker taking BC, you're going to be in trouble, okay? AB is hard enough as it is. But I'm telling you, they're both wonderful courses. Okay, so really, if you want to challenge yourself, come on in, okay? Let's have some fun. They're beautiful symphonies. Everything you do in one chapter leads to the next chapter. Gorgeous courses, really, but they do require a lot of work, okay? So just be ready for that. And if you're taking 7 other APs, it's a lot, okay? BC Calc, I'm not going to say it's as difficult as AP Chem because I never taught it before. We'll see. I can't imagine it being as difficult as AP Chem, so don't freak out. But certainly, a lot harder than AB Calculus because we're doing 25% more material in the same amount of time. So really, it's going to be the pacing in there that's going to be quick. So anyway, if you want to have a discussion about that, let me know, okay? Come to a Google Meet, we could talk about it, or, email me or send me a remind. And really, it's all about putting in the work. You'd be surprised what you can actually handle if you're willing to put in the work, and if you have time to put in the work. If you're taking many AP classes, it's tough to have enough time to put in the work that you need to if, otherwise you might actually do well in this AP if there's only, a couple AP classes. Anyway, talk to me about it if you need to. Tonight, the homework is the take-home assignment that is going to be posted. Tomorrow, you can work on that assignment. So you can do it tonight. You can do it tomorrow. It's going to be due tomorrow by midnight. Next week, we'll slow things down a little bit. I don't know. I might take what's normally like a 1-week thing and make it into 2 weeks just to slow it down at the end of the year. Do some Riemann sums. I'm not sure. Okay, we'll see what's going to happen. Regardless, good luck. Hope you're all doing well. This is Berto signing off, and take it easy, y'all. Adios.